On to the Calvin cycle. So again, we have our NADPH and our ATP, our two energy-rich molecules we are going to be using to power the Calvin cycle. And in the Calvin cycle, there are three major steps to the production of sugar. The first is called carbon fixation. We're going to physically fix or bond carbon dioxide to another molecule. We're going to fix it on there. And then we're going to reduce in the second phase. We're going to add electrons, and you probably know where those electrons are coming from. That's right, NADPH. And then we're going to regenerate that original carbon dioxide acceptor, that molecule we fixed the carbon onto, so we can go through another round of the Calvin cycle. Okay, so here we have the Calvin cycle. Again, many intermediates and many enzymes involved here. We're not in a biochemistry class, so we're not going to be concerned with the names of all of these intermediates. And this cycle is called the Calvin cycle. It is named after the scientist that detailed the cycle, one Melvin Calvin. Melvin Calvin. Thank you, Melvin Calvin. So we're going to start by putting 3 molecules of carbon dioxide into the cycle at a time. Okay? And the carbon fixation stage we're going to take a closer look at. So I'm just taking a look at this very top part of the cycle. We put 3 carbon dioxide molecules into the cycle at a time. And this molecule here, RUBP, ribulose bisphosphate, that is one I want you to know because this is the carbon dioxide acceptor molecule. This is the molecule that we physically attach. So here's a carbon dioxide. We're just showing the carbon for simplicity. Physically attach, you can see the bond, to this RUBP. There's RUBP and here's RUBP again. And we do this by way of an enzyme called Rubisco. Kind of like Nabisco, the wonderful cookie company, but it's Rubisco. Now you need 3 enzymes to do this for each of the 3 carbon dioxides, and you need 3 ribulose bisphosphates. Okay, so this is a very unstable molecule, so it's short-lived, and it's quickly is broken down into 6 3-carbon molecules. Again, I'm not concerned with the names here of these intermediates, but the major point of this phase is again fixing carbon. We are physically putting the carbon onto this very important molecule, ribulose bisphosphate, and doing that by way of a wonderful enzyme called Rubisco. It's delicious. Okay, so here we have one of our intermediates. So in this step, we take the intermediate and add ATP to get our next intermediate. And then we add NADPH, electrons are transferred to the intermediate to produce a molecule called glyceraldehyde 3-phosphate. It's a G3P. This molecule I want you to know. Why do I want you to know it? Because it is a 3-carbon sugar that could be or probably will be used to make glucose. Remember, glucose is 6 carbons. This is a 3-carbon sugar. So we'll need 2 of these sugars, these G3Ps, to make 1 glucose. Now, as you can see, we've added electrons and we've added some ATP. This part of the cycle is called the reduction phase, named for putting those electrons, reducing this intermediate to our G3P, okay, by adding electrons or gaining electrons. All right, so we produce 6 of these molecules, but only 1 of them exits the cycle. Now I know what you're thinking. This cycle seems very greedy. It only lets one of the 6 leave. But there's a very good reason for this. Let's take a look at why this is. And this has to do with phase 3 of the Calvin cycle. That is regenerating our ribulose bisphosphate. We need 5 of these G3Ps in order to regenerate 3 ribulose bisphosphates, 3 5-carbon molecules. 5 times 3 is 15 carbons over here. And we're going to rearrange them by adding ATP. Thank you, light reactions. Thank you for that ATP. To make the RUBP. Okay. So, as we had said, again, you put 3 carbon dioxides in at a time, and you're going to get a 3-carbon sugar out at the end. So for one turn of the Calvin cycle, you get 1/2 of a glucose, let's say. So how many turns of the Calvin cycle would you need to make 1 glucose? That's right, 2. 2 turns of the Calvin cycle. How many carbon dioxide molecules would you need to make 1 glucose? Well, I know I put 3 carbon dioxides in, and I get basically 1/2 a glucose. So I guess I'd have to put 6 carbon dioxide molecules in to get 1 glucose. And that makes sense because, again, glucose is 6 carbons. You got to put in the amount of carbon you want to get out. You don't put it in, you don't get it out. And all these other carbons are just involved in facilitating the process. And again, the ATP and the NADPH, thank you, light reactions. Oh, you're so nice, light reactions. Thank you, light reactions. All right, so I hope this has helped you have a better understanding of this wonderful process of photosynthesis. If you have any questions, please do not hesitate to ask.